right, hello and welcome everybody. We're really excited to have everyone here today for this weekly deep dive series with OCI Product Management. For those of you who may be new to our events, we're hosted on Cloud Customer Connect, our Oracle community forums for end users. You'll see links in the chat throughout the presentation today that lead you back to the Cloud Customer Connect forums. And if you haven't already, we invite you to create a free account, join in discussions, and look for upcoming events on all kinds of topics. I'm Kenna Kettrick. I'm a program manager with the OCI go-to-market team, and today I'm joined by Prabjot and Gopi, principal product managers with OCI. They're going to highlight new releases and networking enhancements, including new load balancer, access and scalability enhancement, virtual network visualization, and more. Before I hand things over, I do have a quick poll. Let's launch that there for you. We do design these weekly sessions with you, our users, in mind. We want to put you in touch with the product managers behind recently launched services. So if you could take a moment, answer that poll, share your thoughts on what topics interest you. We'll happily take this information, use it to design future sessions. We do have 2 events planned next week. On Tuesday, May 18th, we have our monthly OCI Fundamentals series, this time with James Lee, showing how to effectively operate application workloads on Oracle Cloud using automation, monitoring, notifications, and other tools. And on Thursday, May 20th, Gopi's back with a follow-up networking event with our partner, Palo Alto Networks, the deep dive session teaching you how you can use flexible networking load balancer to steer your ingress traffic from on-premises networks to Palo Alto Networks VM series firewalls and connect to your WebSpoke VM. I'll drop links to both of those in the chat window as well, so you can check them out for next week. And I'll also drop a link to the survey that we're running with OCI customers. Since your opinions are important to us, we really appreciate you taking a couple minutes of your time to provide feedback about your experience. And one more quick reminder, please use the Q&A box down at the bottom here of the window for any questions during the presentation. We'll have time at the end of the presentation for extra questions as well. And we are going to record this, as mentioned. So if you have colleagues who are unable to make it, we will be posting the replay, and I'll drop links in the chat for that as well. All right, enough from me. Let's go ahead and get started, and I'll hand it over to you, Prabjot. Take it away.
Thank you, Kenna. Hi, my name is Prabjot Desi, and I'm a Senior Principal Product Manager at OCI. I'm here today with my colleague, Gopi Gopalakrishnan, to provide an update on recent enhancements to OCI's virtual networking product. I'll start with an overview of OCI Cloud Networking. Most enterprises have 5 classes of applications in their portfolios. They have enterprise applications that rely on relational databases, such as supply chain management or ERP systems. These systems require low latency, high performance, and high resiliency because they're critical to your business operations. They have technical computing applications like high performance HPC compute, or machine learning, and examples of that would include engineering simulations that a car manufacturer customers use to predict how new models will perform in crashes, or machine learning algorithms that a bank uses for credit scoring. They also have legacy departmental applications that are used for things such as reporting and analytics, and then web scale applications that support millions of users for functions such as e-commerce and mobile services. And then they often have some cloud native applications that scale horizontally and are meant for the cloud, such as social networks or video streaming. First generation clouds create a new market by producing scale out solutions for the last 2 categories of applications, but they've struggled with enterprise applications. These critical enterprise applications require the ability to scale up. They expect low latency, the ability to have stateful connections to cluster databases, and aren't really compatible with how first generation clouds operate. So to run these applications in the cloud, it would require a complete rewrite, which sounds great until you think about the cost and the time required to do that. Oracle decided to approach the cloud in a different way. So with OCI, because of our heritage with the types of enterprise applications that are hardest to move to the public cloud, we took a different approach. So to deliver this, we focused on building some core innovations to overcome the design limitations of the existing public clouds. These include off-box virtualization, so complete instance, or whether that's a bare metal or virtual machine isolation for higher security and performance. We have custom security ships to ensure that there's a clean compute for every customer, and we follow a zero trust approach. We have a dedicated virtual network that eliminates noisy traffic and ensures clean, consistent network performance for each customer. And we're the only cloud provider to natively support layer 2 networking virtualization. And this currently supports VMware software running in OCI. We have RDMA over Converged Ethernet, which enables HPC, high performance computing, and Exadata performance by scaling processor and memory interconnections directly. And then we have a flexible infrastructure that is flexible to meet customer needs. So custom shapes from 1 to 64 cores. We have adaptive block storage that shifts from the economical to high IOPS as needed, and flexible network load balancing that adapts to demand. With that, I'd like to focus on the products that we have in our OCI virtual networking portfolio. These products fall under 4 categories: application delivery, meaning products that support you as you deliver your applications to your end customers; secure connectivity; and core networking. And we also have monitoring analytics that spans all 3 of those areas. And today we'll be speaking to 6 of these in further detail. OCI now supports IPv6 in all commercial regions. We support both north-south and east-west, which means on-premise to cloud, internet to cloud, and between instances in OCI. IPv6 can now be enabled on your existing OCI resources. So you do not need to create a new VCN and for it to be IPv6 enabled. All your existing resources can now be updated and modified to support IPv6. Or when you make a VCN or enable IPv6 on a VCN, Oracle allocates a /56 global unicast address CIDR range per VCN from our space for you to use. These allocated IPv6 addresses are internet routable. However, you can mark a subnet as private if you do not want your resources to be communicating externally. We've also recently added some enhancements to the DRG, the Dynamic Routing Gateway. You may be familiar with this functionality as Transit Hub or Transit Gateway functionality. We chose to add that to our existing DRG. And so we've upgraded the DRG to support the following features. You can now attach multiple VCNs to a single DRG. So those are VCNs within the same region, which means the DRG can now be used for local peering as well. We support a route table per attachment on the DRG. And as I mentioned, we can have multiple VCNs attached to a single DRG. Those VCNs can belong to the same or a different tenancy. We've also added a single on-ramp functionality for Fast Connect. So you can now use a Fast Connect in one region to reach your OCI resources in another region. We've also added support for equal cost multipath routing towards your IPsec VPN and Fast Connect connections. So the benefits of this are it helps you reduce costs and or supports failure scenarios. So you could have 2 Fast Connect connections from on-premise into different regions. And in the event that one of those fails, you're still able to use the other link to reach resources in both regions. It supports multi-tenancy scenarios for customers that are ISVs or SaaS providers and have services that they provide from a central VCN to end customer VCNs. They're now able to do that through a single gateway to connect with all those VCNs. We also, with the route table, with supporting the ability to have a route table per attachment, it gives you much more granular control of routing. You're able to use routing policies to isolate traffic between attached networks. And as I mentioned, since I did mention we have multiple VCNs attached to a single DRG, we can support up to 300. So you could have 300 local peers using the DRG, which is a much larger scale than we currently have with the local peering gateway. We do plan to retain the local peering gateway. That's not being deprecated. However, with the DRG, if you want to peer with a large number of VCNs, that is the recommended product. And it also actually simplifies configuration because now you're able to just create one gateway and have all your VCNs attached to it rather than setting up a full mesh using LPG. This functionality is currently GA in San Jose and Montreal. Over the course of the next 2 weeks, we will be rolling out this functionality to all commercial regions. So by May 24th, the functionality will be available in all commercial regions. So the DRG serves as a virtual router that's meant to provide a communication path between your private networks. So whether that's a VCN to a VCN in OCI in the same or a different region, or it's to on-premises locations. Some of the use cases of using the DRG, the new functionality added to the DRG is setting up separate development production environments, isolating the workloads of different customers, such as subscribers of an ISP, providing shared IT services to your end customer VCNs, and segregating environments to meet compliance requirements such as PCI and HIPAA. With that, I will hand it over to Gopi to share some more details about load balancer enhancement and network visualizer.
Thank you, Prabjot. All right, for the second half of the session, like Prabjot mentioned, we will be covering enhancements in our load balancing and virtual networking monitoring services. OCI load balancing service provides an automated traffic distribution from one entry point into multiple backend servers in your VCN. And this helps you load balance large amounts of traffic, which could overwhelm a single server. It also gives you a mechanism to scale out your application tier by adding more backend servers and provides you high availability. So even if one availability domain has an issue, you can still be up and running in other availability domains. In OCI, we have a comprehensive flexible load balancing portfolio that spans across application and network load balancing. We support two types of flexible load balancers. The first one is the flexible load balancer, which is a full-featured load balancer as a service that's proxy-based for your layer 7 HTTP and your layer 4 TCP load balancers. And the next one we're going to talk about is the flexible network load balancer, which is a low latency pass-through load balancer for your layer 3, layer 4 workloads. So let's start off with the flexible load balancer, which was launched end of last year. Our goal with flexible load balancer is to enable you to pay only for what you use and provide more flexibility with the bandwidth options. Prior to flexible load balancer, you had limited choices for your bandwidth shapes. You had to choose from one of our 4 fixed shape options of 10, 100, 400, and 8000 Mbps. And not only that, you were charged based on the shape configuration, regardless of the actual bandwidth usage. With this new flexible load balancer, you can define any arbitrary minimum and maximum bandwidth value between 10 and 8000 Mbps. The minimum bandwidth is pre-provisioned and provides you instant readiness for your workloads, while the maximum bandwidth provides you a cost control mechanism. You can scale beyond your minimum bandwidth at any point of time up to your maximum bandwidth value. Our pricing for bandwidth is also very simple and intuitive, where you're charged for the minimum bandwidth if your usage is at or below the min value, or the actual bandwidth usage if it's higher than the minimum. In terms of other advanced features we recently launched, we now support advanced layer 7 routing policy that enables you to present an uniform application URL and route based on conditions within the URL, such as HTTP headers, methods, and query string data, in addition to the URL path and host names. This enables you to support use cases like A/B testing and routing to a specific backend set server based on information such as cookie names in your HTTP header. We have also introduced support for HTTP2 protocol in our layer 7 listeners. Apart from that, we support features like cookie-based session persistence, which allows you to send traffic from one client to the same backend server always. And finally, in terms of security configurations, we support different modes of SSL within the load balancer. You can offload the SSL or terminate it at the load balancer. You can also enable end-to-end SSL from your client all the way to the backend server, or enable SSL tunneling for your TCP load balancers. All right, so let's talk about conversion of your existing fixed shape load balancers to flexible load balancer. You can easily convert your fixed shape load balancers to the flexible load balancer using the update shape option within our UI and the API and the SDKs. As shown in the screenshot here, all you would have to do is click on update shape on the existing load balancer and specify the minimum and maximum bandwidth value that you want to convert this load balancer to. If you wanted to mimic the same exact behavior as your existing fixed shape load balancers, all you would have to do is to configure the minimum and maximum to be the exact same values. Okay, now let's talk about the new flexible network load balancer, which was launched last month. So the NLB complements our flexible load balancer. And this one is a non-proxy pass-through load balancer that is highly scalable and scales up elastically based on your incoming client traffic. Unlike the FlexLB we just talked about, it does not have a notion of shapes or require any bandwidth size configuration. It's mainly targeted at customers requiring low latency, high throughput pass-through load balancing for your layer 4 TCP and UDP workloads. It is also optimized for long-lived connections in the order of days. And being a pass-through load balancer, it's capable of preserving your client header details, which makes it ideal for you to support database type applications, as well as use cases like scaling of your network virtual appliances like firewalls. And last but not the least, the network load balancer is offered as a free service at no cost to our customers. Okay, so this use case here builds on our VCN transit routing feature and the DRG enhancements that Prabjot was talking about earlier. In this scenario, we have a firewall cluster that's hosted behind a flexible network load balancer. And the flexible network load balancer is configured as the next hop to the DRG. And in this case, all the traffic that's coming in from your on-premises network to OCI is funneled through your DRG. And as shown in the diagram, the user traffic that would otherwise flow directly from source to the destination is now routed through this firewall instance cluster hosted behind NLB using VCN and DRG route tables. In this specific mode, the NLB acts as a bump in the wire layer 3 transparent load balancer that does not modify the packet characteristics and preserves the original client IP header. This enables your firewall appliances to inspect the original header and apply security policies before they forward it to the backend servers or the actual application backends that's hosted behind the flexible load balancer in this web spoke we see in this example. All right, let's look at a short demo for our new network load balancer. In this demo, we have an example of a customer known as MewShop. This customer has an e-commerce site for cat products built as a set of microservices on OCI. MewShop has recently introduced a new video streaming feature in their website to showcase user-submitted videos. We will show you how to create and use a network load balancer to host and scale that video streaming service following these 3 steps.
First, we will create the network load balancer. Let's start by giving it a friendly name. We will call it MewShop Media NLB. We will create the network load balancer with public visibility to serve clients coming in from the internet. We will assign an ephemeral IP address, which will automatically assign an IP address from Oracle's pool. Now we will select the appropriate network placement. Then we will attach an NSG to secure the NLB. Next, we will configure a UDP and TCP listener using any port. As a final step, let's attach the backend media service to the NLB and specify an appropriate TCP health check policy on port 5080. While the NLB is provisioned and created, let me switch to a setup that I have up and running for this demo. Prior to starting this demo, we initiated a load test to simulate a normal traffic pattern from MooShop. The average traffic pattern for MooShop e-commerce is a few hundred users watching cat videos in real time. A few moments ago, a user decided to post this super cute cat video, and you will see a spike of several thousand viewers watching this video. We will simulate that by adjusting the value to 1000 in our load test tool. You can see the traffic associated with those connections starting to appear in this graph. Shortly after, a celebrity posts the same cat video on his social media, and suddenly the MooShop instantly receives a massive influx of requests from several thousand viewers. The Flex NLB is able to handle that workload seamlessly, as you can see here, even though the traffic processed by the NLB has increased exponentially. Now you can see even with the additional load, the experience is seamless for new MooShop customers. Here's another video. And another video. And one more for good measure. In summary, we saw how easy it was to set up an NLB, as well as how it scales up rapidly and automatically to support peak traffic.
All right, so now let's switch gears and talk about enhancements in our virtual networking, monitoring, and analytics services. The first product we're going to talk about is the new network visualizer that was launched last month. The goal of Network Visualizer is to enable you to view a high-level structure of your entire networking configuration and to facilitate quick navigation between your core VCN components. Network Visualizer takes your current topology and abstracts it into a visual model. And through interaction with this model, you can get detailed resource information for each one of those components, allowing you to view and manage the configuration of those components with a single click. It also helps identify and troubleshoot issues within your network, such as misconfigurations. All right, here's a quick demo of our network visualizer. What we're showing here is the current view of a hub and spoke architecture, where you have a CPE in your on-premises network that's connected to a DRG through an IPsec tunnel. And the hub and spoke VCNs are connected through the DRG and LPG peerings. Now let's take a look at how that topology has evolved with the DRG enhancements that Prabjot was talking about earlier. So now you no longer require those LPG peerings, and you can connect multiple VCNs with a single DRG and a route table attachment per VCN on that DRG. And with this enhancement, you can create peering connections, both local and remote, with up to 300 VCNs. All right, so the next visualization product that we're going to talk about is the interregion latency dashboard. We have now introduced the ability to view real-time and historical latency for your OCI regions across the globe. As shown in the snapshot here, this information is presented to you in a grid format, allowing you to easily see the real-time round-trip latency between any given region pair. And by clicking on a specific region pair, you can view both the detailed historical latency as well as real-time latency. You can also configure alarming and event notifications based on this information. And specific use case for this information, you can use this for planning your data center deployments. You can use this to do enhanced troubleshooting for your application performance, and also in general, optimize your cloud infrastructure. We provide you historic snapshots that include up to a 30-day history, within which you can also zoom in into 1 hour time intervals within that snapshot. All right, so here's some additional information on the firewall scaling use case we spoke about with our new network load balancer. And there are some reference materials from our partners at Palo Alto Networks and Checkpoint. We are in the process of integrating and validating the solution with a few other partners like Fortinet and Cisco. As Kenna mentioned earlier, do join us next week to hear directly from our partners at Palo Alto Networks on this integration and best practices to deploy and scale your Palo Alto virtual appliances in OCI. Here's some more additional information on best practice guidance and reference architecture for the networking products and services we talked about. You can also refer to the blog links here to learn more about the products. With that, we can open up the floor for some question and answers.
Thanks, Gopi. So I think one of the questions that came up, and this has come up before, so I wanted to just address it, is do we plan to either merge or get rid of the LPG since the DRG can now be used for local peering? The answer is no. We plan to retain both products for now. There's no current plans at this point.
And Gopi, we have one pending question inside of the chat or the Q&A. It's any plan to add packet tracing visualization to the network visualization tool?
Sure, John. Yeah, that is definitely part of our product vision. So we would definitely be interested to learn more about the use cases that you're trying to address with such a tool. So if you can email either John or me directly, that will help us in validating that.
Yeah, and our email address is firstname.lastname@oracle.com for both Gopi and I. We have one. Do you have a blueprint for dev, test, and prod to create private subnets with a VCN? I do believe we have Terraform templates to create those different environments on our GitHub repo. I'll see if I can track down the link real quick. It looks like those are the last two questions at the moment.
Perfect. With that, let's hand it back to Ken.
All right. Excellent. Oh, we got one more question come through.
Yeah, I see that. So it says, new DRG direct VCN approach seems to remove the LPG peering. We currently, the LPG peering limit we currently have with transit routing, are there any limitations we need to consider other than the 300 VCNs limit you mentioned? The other limitation is we only support 100 route tables per DRG. So I know I mentioned you can have one per attachment. So you can assign a route table to each DRG attachment, but you are limited to 100 route tables per DRG. And that's a soft limit, so it could be increased, but that would be the one other consideration. And there's another question asking if it's possible to NAT a private address to another private address in a VCN. The answer is, so I think you're asking if the DRG supports NAT functionality. And the answer is not at this point in time. But if you have specific use cases, please do reach out to us, because we're always looking to gather requirements for new features and functionality.
And there's one more question. Is there guidance for local peering with DRG between different cloud tenancies? Any guidance who should own the DRG in the routes?
Misha, can
you take that one?
Yeah, I think it's going to primarily, while we can support this functionality, it's going to depend on who should be put in charge of managing the DRG and the related routing. If both sides need to manage that functionality, there needs to be a sense of ownership there on who's going to own that and control that routing. But really, it's going to come down to the management of the routing and who needs to take ownership of it.
We have another question. What is the bandwidth limit of a DRG?
What specifically do you mean by bandwidth limit? Because we have Fast Connect, you've got 1 gig, 10 gig, and then there's the IPsec VPN, which is about, it's a 250 Mbps.
I think you covered the limiting factors there. I don't think there's any other limits other than those.
Okay.
Okay, could you give an example of when to choose network load balancer over LBAS? So specifically, if there's a couple different scenarios, if you want like a low latency video streaming type application, or you need UDP traffic, for example, you need ICMP traffic. Those are some reasons. Generally, if you have any sort of scaling limitation that would exceed our maximum size of the load balancer instance, that's another reason. But generally, it's application specific, different requirements for different applications. Currently, our network load balancer doesn't support TLS termination. So if you want to terminate TLS as the load balancer, you would go with LBAS. So there's a lot of different scenarios there, but it's really application specific. But those are the primary reasons. And there's a question about, can we get a recorded session of this meeting?
I think the answer to that is yes.
Yes. Yeah, there are. So I dropped several links in the chat. One of which is a link specifically to the event post about this event, which will have the recording posted, as well as the slideshow. And if you want to save the chat, if anybody wants to save the chat, you can go open that chat window, and the little 3 dots on the corner where you would send a message, you can click that and save chat, which will have all the links that I dropped in there. So it has the link to this specific event and also to our previous event calendar. I had some questions in the chat too about previous events that may have shown up here. So if you want to go back in there and take a look at other events that we've had, or if you have questions that come up afterward and you want to start a forum post and go and like ask questions about that, those are all links to get you to our CCC forums where you can continue that discussion and find the resources that were posted in this slideshow as well. So please feel free, save that chat information, take it with you, continue the discussion and investigate more in there. I am going to throw up one final poll for the folks who are here. So always appreciate a little feedback there. And I want to give a really big thank you to Prabhat and Gopi for this presentation, and John and Daniel and Misha for answering the Q&A as we went through. As I mentioned, please save that information that's in chat to go take a look at various other things as well. And if you are free next week, come check out those 2 that are happening next week and other future events too. So thank you so much, everybody, and have a wonderful rest of your day.